Today we're going to continue on with the digestive system, and what's kind of nice as we go through the digestive system, we are working our way top down. So we're going through all of the tract plus hitting up some of the accessory organs along the way. We ended last time with the liver. Kind of started it, we didn't get too far into the liver. But what is kind of nice is some of lecture today is a nice review for your lab quiz. So whether you have lab after this or if you have it tomorrow, and I'm like, it's a nice review from different parts of the digestive system. And so we've got various types of ducts. We have a common hepatic duct that leaves the liver, that's transporting bile. You have a cystic duct that's coming just from the gallbladder. And then you have a common bile duct when the two join together that will dump into the duodenum. Again, the duodenum is the first part of the small intestine. It's the shortest part of the small intestine, but really most interesting stuff happens there. And part of it is because you have all the bile coming from the liver and the gallbladder, and you have pancreatic juices that are all dumping in to the duodenum area of the small intestine. Never lets me click it right away. There you go. Now, inside the liver, if you could cross section and then zoom in even more. The inside of the liver has little, I call them lobules. They're hexagonal shaped. So it's not just everything's boring inside of our body. We get a little, creative. We've got little hexagonal lobules inside the liver, and they are made up of hepatocytes, which are cells found in the liver. It's part of its name. And it's inside these lobules, because you do have a central vein, that you have lots and lots of blood flowing through your liver. Like lots. It's there to filter, it's there to process, it's there to remove nutrients, it's there to add nutrients into the blood as it's filtering through the liver. Now, that in itself doesn't really do digestive stuff, but the liver does a lot of filtering of blood. Now, if we zoom in on those lobules, again, has a hexagonal shape. At each corner, at each edge of the hexagon, it has what's known as a portal triad, which means it has an arteriole, little artery, it has a venule, little vein, and it has a bile duct. So you've got lots of blood flow going through the liver, but you also have bile that's getting made there as well, and the bile has to leave the liver as well. So you've got various types of bile ducts and transport inside the livers. Now, the cells of your liver, they process bloodborne nutrients, they store fat-soluble vitamins, they perform detoxification on various ammonia-type nitrogen chemicals, but the most important digestive system function that our liver does is that it makes about 900 milliliters of bile a day. It's almost a liter, because 1,000 milliliters is a liter. So it makes almost a liter of bile a day. You make a lot of juices. You make gastric juices, you make intestinal juices, your liver makes bile, and I'm like, we'll get to the pancreas today as well. You make a lot of juices inside your body. Now, an interesting factoid about the liver as an organ itself, the liver can regenerate. It's the only organ that other than your skin is technically an organ, it's really the only organ inside the body that has some regenerative capability. Which means if you remove 80% of it, it can actually regenerate what's lost. It can take a little while, but it can actually start to grow. So if there's any injury, your hepatocytes will trigger the making of growth factors, which is going to cause endothelial cells to divide. And so you can replace, and I'm like, if people have to have part of their liver removed, they can survive with it, and it can even regenerate. Now, and I'm like, you can't remove the whole thing because you need still at least 20% there to be able to regenerate. Now, things that can happen to the liver, one of the biggest ones that can happen to the liver is hepatitis. Itis, and at the end of anything, means an inflammation. It's liver inflammation. One of the top things that cause hepatitis are various types of viruses. There's hepatitis A, hepatitis B, C, D, E, and even F. Those are all viruses that can cause inflammation of the liver. There are various types of drugs that can cause inflammation of the liver. There's even certain types of mushrooms that can cause liver inflammation as well. So I'm like, we can still cause our liver to be inflamed. Big characteristics of hepatitis, Well, your liver is a huge organ over on the right side of your body. If it's already big, it's going to become even bigger. It's going to be painful. So you're going to have a lot of pain right where your liver is. But another big characteristic of hepatitis is you're usually going to have jaundice as well. That inflamed liver is not doing its job, and you're going to have bilirubin circulating around your blood. If we damage the liver enough, it can cause what's known as cirrhosis of the liver. This means small amounts of damage. It's a slow, progressive damage to your liver. That as you damage the cells in your liver, and although, yeah, they can regenerate, but if you are constantly damaging cells in your liver, although they may be trying to grow, scar tissue can grow faster. And you'll end up with a liver that looks more like that. And I'm like, it's from chronic, and I'm like, hepatitis, chronic inflammation doing damage. Alcohol can cause inflammation of the liver. And I'm like, and enough of it causes enough damage that scar tissue replaces the cells. And you almost get this kind of, they look like little lobules, that scar tissue kind of pulls in on the liver. The liver should be nice and smooth. It shouldn't be bumpy. That scar tissue that's pulling down on the liver tissue itself. Now, if we start to damage that enough, and I'm like, you have more of just a fatty, fibrous liver that's not filtering blood, it's not making the bile that it requires, and you can end up with something known as portal hypertension. Pretty much your liver is shutting down. Now, if that happens, if people realize they're getting to, the point they've damaged their liver so much, they can get put on a liver transplant list, but livers are scarce. You can be on liver transplant lists for years and may or may not get one. And I'm like, luckily, liver transplants are one of the most successful transplanted organs. You just have to be able to get one. Well, any organs are scarce. And I think partly this is one that, for a lot of organs, the reason why they need a transplant is you were born with some type of damage. This can be done. Like, you can have lots of alcoholics that are going to damage their liver. It's not just something you were born genetically with. We did it to ourselves. Now, the bile that it makes, again, one of the most important digestive functions of the liver is to make bile. It's a yellow, greenish colored fluid, which is why on every single picture you ever see of the gallbladder, it is a green color. There's a reason why they always shade it in green. And I'm like, it is green. It is truly green. Only reason it's not green on our cadaver, because it was. It's just sitting in the juices. It's leached out the color. And I'm like, but it is green. The gallbladder is green because of the bile that's stored in it. It is an alkaline solution. It's to help neutralize the acid in the duodenum from that acidic chyme that's going in there. And what's in the bile? Big one is bile salts. Reason why we want the bile salts in that bile, it helps start to break down fats. It's a fat emulsifier, which means it will take one big blob of fat and break it down into smaller blobs of fat. It's easier to digest. It's easier to eventually break it all down. So the bile salts help with that. There's also a pigment in there that gives it its color. The pigment comes from heme, the heme part of hemoglobin. And so the bilirubin is the pigment that came from the breakdown of heme. Again, we've got those in our red blood cells. We have hemoglobin molecules in there. Well, we're constantly recycling everything we have, and we do break it down, but some of that heme does get filtered in the liver and becomes a pigment known as bilirubin. Now, eventually, that bile that dumps into your intestines, with that bilirubin, with that pigment, bacteria break the bilirubin down into another pigment called stercobilin. And the stercobilin pigment is why your feces is always brown. It doesn't matter what you eat. I mean, there's a few things that can make it some funky colors. And I'm like, but there's a reason why your poop is always brown. It all comes back to your red blood cells. And I'm like, as long as you have red blood cells, as long as you have hemoglobin, your feces will always be brown. And I'm like, it's the pigments from the breakdown of the heme that causes your feces to be brown. Now, other thing that we find in some bile, we do find some cholesterol. There are some fats in there. There are some phospholipids. There are some electrolytes. And I'm like, but mostly it's the bile salts and the bilirubin. And I'm like, that gives it the color, and why we need it is the breaking down of fats. Now, the gallbladder's job is store that bile. It can concentrate it as well, but it doesn't make the bile. The liver makes the bile, but that bile can get stored in the gallbladder and concentrated. So we can remove some of the liquid in the bile and concentrate those bile salts in there. So it's just a little thin-walled muscular sac. It sits right underneath the liver, stores and concentrates bile. It removes some of the water, removes some of the ions, and after you ate something, primarily something that has lots of fat in it, the gallbladder will contract, and some of the bile will go through the cystic duct into the common bile duct and into the duodenum to start to break down those fatty foods. Now, can you survive without your gallbladder? Yes. I'm like, you can survive without your gallbladder. All it does is store and concentrate bile. You can remove it, you still can make bile. Your body will start to adjust to not having a gallbladder. It takes a little bit. And I'm like, but you can still make bile. You can still put bile into the duodenum and break apart your fatty foods. One of the biggest issues that people have after having their gallbladder removed, at least initially until their body realizes and starts to adapt, is that when they eat fatty foods, if you don't have lots of bile going in there to break down those fats, the fats are going to go right through you. And I'm like, and they end up having a fatty diarrhea. And so I'm like, after having gallbladder removed, you have to limit the fat intake until eventually the liver can make more bile so that it's needed and readily available after you eat something that has a lot of food or a lot of fat in it. Now, problems that can happen with the gallbladder, which is the main reason why it gets removed, are gallstones. Usually happens too much cholesterol in your diet, and there's not enough bile salts to break it down. It can actually cause crystals to form in the gallbladder. And so it's that crystals, the stones, they're not just nice round stones. They are bumpy, they are jagged, and when your gallbladder contracts on something sharp and jagged, it's gonna hurt. And that's the main thing. It's pain right there. And if you get enough gallstones in there, they can obstruct bile from flowing out of the gallbladder. Now, treat it. They can try to give you some drugs if it's not too bad that can try to break them down. Otherwise, they can do ultrasound vibrations right there to try to break apart the stones. They can try to do laser vaporization to try to break apart the stones. And they can also try to surgically, well, they don't usually surgically remove the stones. They would just surgically remove the gallbladder. Because generally, if you are prone, or if you get gallstones once, you are more prone to get gallstones later on in life. Now, because I was hoping to get there last time, but I didn't. But let's review, and like granted, some of these questions are from last Tuesday. Man, it's been a week. So a lot of these first questions are from last Tuesday, way long week ago, is where is chemical digestion initiated? I was like, we just went over that.
Yes, we did.
I was like, chemical digestion starts in the mouth. That's where carbohydrates can start to get broken down chemically. What is the possible side effect of having a weak cardiac sphincter? I was like, you all had it. I'm like, yes, it's acid reflux. Thank you for not putting yellow. It's acid reflux into the esophagus, that acid is going up in there, causing damage. Oops. Why did it go to the beginning of my PowerPoint? Ooh, I hit the wrong button, apparently. Oh, yep. I know. That's why I'm like, I don't know what happened there. There's more. This involves over 22 muscle groups and includes the buccal phase and a pharyngeal esophageal phase. Maybe I shouldn't touch anything. So which of those includes 22 muscle groups and has a buccal phase and a pharyngeal esophageal phase? It's deglutition, which is swallowing. And I'm like, it's the swallowing process. But of course, we just don't call it swallowing. The stomach is able to expand to nearly 100 times its empty volume, partly due to what in its walls? It's the rugae, all those kind of bumpy, wavy things inside of the stomach that allows it to really stretch out after big meals. A patient with a low red blood cell count receives vitamin B12 injections every 2 weeks. Why? I was going to say, it is the yellow. The parietal cells in the patient's stomach have stopped making the intrinsic factor, which means they're not getting enough of the vitamin B12, which means they aren't making enough red blood cells.
Wouldn't it be O2?
Low iron wouldn't need vitamin B12. That
doesn't help produce.
Nope. And I'm like, vitamin B12 is just the making of the red blood cells. You wouldn't get a B12 injection. You would just be told to take more iron. When your stomach growls in response to an ad on TV for food, what phase of gastric secretion is initiated? Were you growling?
I was thinking of my Kit Kat.
Or thinking about food, or talking about food, or hearing people talk about food, and all of a sudden your stomach starts to growl. It's usually loud and really embarrassing, because it's always at the quietest time. It's the cephalic phase. Anything cephal means head. It's pretty much you are seeing food, hearing food, smelling food. That's all part of the cephalic phase, and your stomach starts to growl. What cells are responsible for hydrogen chloride production? It is the parietal cells that also make the intrinsic factor. A meal high in fat would do what? I was like, yep, you should always listen to Carmen. And I'm like, it is the green. Anything that's in fat, I'm like, fat stays in your stomach the longest. It stays in your duodenum the longest. You know, random gross factoid is if you have eaten like 2 hours later after you ate and you threw up, within 2 hours your stomach should be empty of everything you ate except something fat. Your vomit will be oily. And I'm like, because it's whatever fat is left in there. Fun factoid next time you throw up. Right around there, because anything else would go through right away. Your carbohydrates will go through first, the oils, the fats hang out the longest.
Let's say you only eat one meal, throw up, but it's not like 2 hours after, would you basically just do that?
If it was shortly after, yeah, it'd be whatever was still in your stomach. So it might look like some of the food you ate, it might not. In what way is the small intestine well adapted for nutrient absorption? It is the yellow. It's got a lot of surface area. It has circular folds in it, and it has villi, which are like folds on top of the folds. Then it has microvilli, which are literally folds on top of the folds on top of the folds, so that you have a huge surface area. I think they said if you could spread out all of the microvilli, the villi, and the circular folds, it's about 2,000 square feet, which for a lot, you know, that's more than the common average house. And I'm like, and it's about the size of a tennis court. You know, I'm like, I think a full tennis court is around 2,000 square feet. The gallbladder, blank bile by blank water and ions. I want to say, I'm like, although it does store bile there, it doesn't prevent the absorption of water and ions. Instead, it does absorb water and ions. And so it concentrates bile by absorbing water and ions. But yes, it does store it, but the last part didn't fit. Sorry. Last one in this group. Cirrhosis of the liver would most severely impact digestion of what? If you damage your liver. It's the green, the lipids. It's the bile that the liver makes that does that fat emulsification. Your other things, the carbohydrates, the proteins, which make up the amino acids, or amino acids make up the protein, that all comes from pancreas enzymes. We get to the pancreas next. So another accessory organ hangs out right below the stomach. And the pancreas does a lot of things. We cannot survive without the pancreas. It is one that we can't survive without. Now, it has various endocrine functions and it has exocrine functions. Endocrine functions, anything endo, it means there's no duct. It just secretes hormones, specifically right into blood supply, right into lymphatic supply. And the two hormones that the pancreas makes, one, it secretes insulin, which lowers blood sugar, and it can secrete glucagon, which raises blood sugar. No, that's not really digestive system function, but it is an endocrine organ as well as a digestive organ. The exocrine function, meaning it secretes whatever fluid it makes into a duct, and there is a pancreatic duct, because you have to be able to know it for your lab, is that we have cells that are inside of there. They're acini or acinar for singular. These make more juices. They make pancreatic juices. And it's in these juices where you have lots and lots of enzymes. And so they're going to secrete their juice through various ductworks, through eventually the big, huge, common pancreatic duct into the duodenum. So you've got pancreatic juices dumping into the duodenum, you've got bile dumping into the duodenum, and it's really to start getting that breakdown of the food once it gets to the duodenum. Now, your pancreas makes about 1,200, 1,500 milliliters. That's, up to 1.5 liters of pancreatic juices a day. And you make a lot of juices. Now, the pancreatic juice is watery, but it is alkaline. It has a pH of around 8. Part of that is to help neutralize that acidic chyme. The food that leaves your stomach is acidic because your stomach is so acidic. And so we've got juices that are right there dumping into the duodenum to try to help neutralize that acidic chyme in there. Now, part about what makes it alkaline is that it's got bicarbonate ions, but it has a lot of enzymes. And again, enzymes usually, but not always, usually end in ase. So it's got amylase, which breaks down carbohydrate, lipases, which break down lipids. It's got nucleases, which break down nucleic acids. Most of these are secreted in active forms, which means as soon as they go into the duodenum, they are ready to break your food down. And then we also have proteases, which are just enzymes that break down proteins. Now, most of the proteases are secreted in an inactive form, but they become active right after they get to the duodenum. So I'm like, protease, these are just enzymes that break down proteins. Various types of protease enzymes that you have in there. You have something known as trypsinogen. And again, these are all secreted in inactive forms, but then become active to break down proteins. Now, trypsinogen, it has that gen in it. Gen means generate or making. So it hasn't made anything yet, but it's going to make trypsin. So trypsinogen is the inactive form. When we remove the gen, you just have trypsin. Same thing with chymotrypsinogen. That's inactive. When you remove the gen, you just have chymotrypsin. And then we have procarboxypeptidase. The pro means before. You remove it, and then you just have carboxypeptidase. So the inactive forms always have some part of the word in there that tells you it's an inactive form, and then they get activated. Now, the trypsinogen activating to trypsin is kind of the big enzyme that activates everything. How this becomes active is that the cells that line your small intestine, secrete chemicals that activate it. So they started off, trypsinidin becomes active. The trypsin can actually activate more trypsin. It's a positive feedback cycle. But the trypsin also activates this one and also activates that one. So as long as you've got your small intestine and you've got some cells there that can activate trypsinogen, you now have all of your protease, all of your protein digesting enzymes ready to break down the food you ate. Now, regulating, because you've got bile coming from the liver and the gallbladder, and you've got your own pancreatic juices. They're all going to dump into the duodenum. And so there are a couple things that regulate when they get dumped into the duodenum, because they're not constantly just put in there. And so your bile and pancreatic juices, they are stimulated by both neural control. Just even seeing food can trigger the dumping of those secretions in there. But most of it's hormonal control. And the top two hormones that can control bile going into your intestine and pancreatic juices going into your intestine is the cholecystokinin, which we just shorten it to CCK, and a hormone called secretin, because it causes secretions. It's nice when they name things like that. Now, regulating of the bile. And like before we get to the pancreas. One, bile secretion. This is really the making of bile, getting it into the bile ducts so that it can leave the liver. Part of it is if you have any bile salts anywhere in your intestine or the liver itself. The bile exposed to itself makes more bile. Otherwise, it's the secretin. The secretin is the hormone that comes from your intestinal cells when it is exposed to fatty chyme, which means you just got done eating something that had fat in it. It goes through your intestinal cells realize there's fatty chyme there, and your intestinal cells start secreting the hormone secretin. It's like, okay, well, we see some fatty chyme. We probably should tell the liver to start making some bile and start secreting it ASAP to break down that fatty chyme. Secretin is being released to do that. Now, your hepatopancreatic sphincter, I wonder if I have a picture close enough. Your hepatic pancreatic sphincter there is a sphincter right here, so that bile and pancreatic juices don't just dump in. There's a sphincter that stops that. So it is normally closed. So that sphincter is normally closed unless you're actively digesting something. Then we'll open it up to put that bile and put the pancreatic juices in there. And so I'm like, you only get bile in there when the bile squeezes, it contracts, and I'm like, and dump some of the bile into your intestine. Now, your gallbladder is not just going to contract to get bile out of it. That cholecystokinin, the other hormone, triggers your gallbladder to contract, to squeeze down, to get that bile out of the gallbladder, down into your intestine to break apart that fatty food that you just got done eating. Because again, you have now acidic fatty chyme in your intestine that needs to get broken down by that bile. Now, cholecystokinin is the big hormone that causes the gallbladder to contract. Vagal stimulation, just that's up in the cephalic phase, seeing food, having food just in your mouth, the chewing of food, anything kind of head-wise, smelling food, seeing food, even chewing on food can trigger the gallbladder to contract. It's mostly the hormone. So cholecystokinin causes your gallbladder to contract to get bile into your intestine to break apart that fat, but it also causes your pancreas to start secreting pancreatic juices and to cause the sphincter to relax, because you have to get it all out of there. So if chyme is in the intestine, because you just got done eating something, that cholecystokinin produces those enzyme, lots of enzymes, enzyme-rich solution. That CCK that made the gallbladder contract tells the pancreas, well, there's fat in there, and if there's fat in there, there's probably carbohydrates. And I'm like, there's probably some proteins. There's probably something else. We need to get not just bile salts in there, not just bile. We need to get all the other enzymes. So CCK causes gallbladder to contract and for your pancreas to start secreting its juices. And then the secretin causes the bicarbonate part. The fact that it's not just enzymes, that it also has that slightly alkaline, high pH part of the juice to go into that pancreatic duct. So you now have a alkaline solution that has lots of enzymes. And I'm like, most chemical breakdown of your food happens in the small intestine. And it's really because of the pancreas, because it has so many enzymes to break apart your food. Now again, vagal stimulation, seeing food, tasting food, and I'm like chewing on food, minor stimulus for creating the pancreas to make the pancreatic juices and secrete it. It's mostly the hormones CCK and the secretin. Now the picture that shows that, it's like, I don't even know why I throw it up, because then I'm like, I break it down. It's like, so much, not so much. So you just got done eating a meal, whatever it is, and you start having chyme. Again, it's slow amounts of the chyme dumping into the intestine. Well, the fact that you now have a fatty chyme in your intestine is going to trigger those cells in your intestinal wall. Like, we need to start making the cholecystokinin, the CCK, and secretin. We've got food incoming. We need stuff to help break it down. That's the part that triggers it all. So the CCK, which are the little red dots, and your secretin, which are the little yellow dots, are both going to get released. And I'm like, they're going to go into the blood supply. And your CCK is going to tell your pancreas to start making enzyme-rich pancreatic fluids. And the secretin is going to tell the pancreas to start making that bicarbonate-rich, high pH fluid. It's those same two hormones are eventually get up to the liver, go into the liver to cause your liver to start making bile, and will cause your, gallbladder to contract. The CCK is what's really causing the gallbladder to contract. That's why there's only the red going to it. And so that you've got bile getting made, and you've got that gallbladder contracting so that you can now have bile dumping in there, which you've got the little green dot. Now, my little note is there are nerves as well. The vagal stimulation, the fact you're chewing on food, seeing food, smelling food, that can also trigger the gallbladder to contract as well. It can also tell the pancreas to start to make some of these fluids. It's mostly all run by hormones, the secretin and the CCK. Now, digestion in the small intestine. Most of your food is broken down in the small intestine. And again, it's mostly because of all the bile salts from the bile and from all the enzymes that comes from the pancreas. And so the chyme from the stomach, and I'm like, sometimes it resembles food, sometimes it doesn't by the time it gets to your small intestine. But you've got some partially digested carbohydrates, because they did start to get digested up with your saliva. And you've got lots of proteins, and you've got undigested fats, because fats haven't even been touched till it gets to the small intestine. Food can hang out for about 3 to 6 hours in your small intestine. It is slowly making its way through. Most of the water gets absorbed in the small intestine, and you have to think too, all the juices, that's 1.5 liters of pancreatic juice, a liter of bile that you made, all your gastric juices, and I'm like, all the saliva you make in a day, all of the water from those juices, because they are mostly water, are going to get absorbed in the small intestine. And then almost all the nutrients absorbed in the small intestine. So lots and lots of absorption taking place in the small intestine. The small intestine has no role in ingestion, it has no effect on what goes into the body, and it doesn't have any role in defecation. That comes later, after the small intestine. Its main job is to break apart food and absorb it. And it's got lots and lots of surface area to do that. Now, requirements for digestion to happen and absorption to happen. One, you need a slow delivery of acidic hypertonic chyme. We need the slow delivery. It's acidic. It's coming right from the stomach. We can't have large amounts of acid going into the small intestine. So that's the small amounts. And I'm like, we also need small amounts because the food chyme, and I'm like, that's going in there, it's hypertonic, which means it has lots of acid, it has lots of solutes in it, and if you have lots of solutes going into the intestine, water will want to leave your intestine to go where there's not as much water. And it would cause your intestines to literally shrivel up and dry out. So we have just small amounts at a time, so that doesn't happen. We also need a constant delivery of bile. We also need a constant delivery of enzymes that's coming from the pancreas, and we need a constant supply of your bicarbonate ions from the pancreas to help neutralize that acid. And then we need lots of mixing of all of it. Like, let's mix the food, let's mix food. And I'm like, let's mix the enzymes, let's mix everything up so we can have breakdown and then absorption. Now, what helps move stuff along and what helps mix is what's known as segmentation. It's the most common motion of the small intestine. So when food goes in, it is going in small spurts at a time, but it's kind of a constant spurt. Segmentation helps move food along, but it's squeezing in on itself, creating little tiny segments. But when it's doing that, it's not just wanting to, to make segments happen. It's mostly trying to mix the food along. As it's squeezing on food, it is mixing the food with those enzymes with the bile salts. And I'm like, the intensity of, little squeezes to big squeezes, all run by different types of reflexes and your nervous system, as well as a few hormones. Your parasympathetic nervous system, which is your rest and digest, we're digesting, so your parasympathetic nervous system is going to create, cause this to happen a lot. Your sympathetic nervous system, when you're under stress, is going to slow all this down, because when you're stressed, you're not digesting. And as you get to the end of, the digestion phase, when we don't have food in there, it slows down. We don't have food in there. Why keep squeezing? So this helps mostly with mixing, is this constant squeezing. Eventually, what's moving it from point A to point B is that as there's some squeezing with segmentation, the smooth muscle is almost like squeezing in a downward motion as well. That's peristalsis. It's your smooth muscle that is moving the food from point A to point B. It can be getting segmented along the way, but it's doing like one big squeeze from point A to point B. And it only goes one direction. It's why you can eat upside down and food is still going to go from point A to point B. And it's that peristalsis, that forward motion. Segmentation is just squeezing it and mixing it along the way. Now, what triggers peristalsis? Another hormone, motilin. And I'm like, and it happens, and I was going to say, about every 90 to 20 minutes, and I'm like, that you get an increase of this hormone to cause more squeezing. And so that meal remnants, we don't like to call it food anymore, any bacteria that might be in there, any other debris, will move their way out of the small intestine. So it's slowly making its way through. Now at the end of the small intestine, you have your ileocecal sphincter, because the last part of your small intestine is the ileum, and the first part of the large intestine is the cecum, so between the two is the ileocecal sphincter. And so when food gets to that point, that sphincter has to relax, allow food to go from small intestine to large intestine, and then it closes. So food cannot go from large intestine backwards. Again, our intestinal tract is a one-way direction. Never goes backwards, unless it's vomiting, but we'll talk about that too. No, we already talked about that last time. And I'm like, otherwise, one-way direction. Now, there's a couple reflexes that help move things along to make sure we get from point A to point B. One is called the gastroileal reflex that forces more of the segmentation in that last segment, the ileum part, that hopefully will push as well some of the food into the cecum. Gastrin is a hormone that increases motility, getting food along the small intestine. But once the food makes it into the large intestine, I was going to say, the valve, the sphincter, closes. And I'm like, if chyme tries to go backwards, it's going to remain closed. It prevents regurgitation of food back into the ileum. Once food is in the large intestine, it cannot go back into the ileum. It cannot go back into the small intestine. So we've made it to the large intestine. It was in the ileum. They don't show it all. And I'm like, there's your ileocecal sphincter, ileocecal valve. We've now made it into the large intestine. Now it's large, not because of the length. And I'm like, it's large because of the width. It's about 2.5 inches. And I'm like, it's large width-wise. Now, a couple features of it, looking at it from the outside. One is what's known as the tinea coli. There are bands of longitudinal tissue that run right through it. And I'm like, part of that, it just gives a little bit more of its structure. I'm going to say structure. And I'm like, fact it can't stretch as much. It gives it some of its, shape, that it can't stretch any particular direction. It also has what are known as haustra, and I'm like that we have these little tiny sections. That it's not just one big huge, uniform looking tube. You have these almost little tiny pouches. They call them pocket-like sacs. And I'm like, little tiny pouches. Part of that is from the smooth muscle that runs through it and can cut in on it sideways. You get these little tiny pouches. And we also have these little tiny yellow, these are little tiny fat-filled pouches that hang on the outside. One, it's fat that's just hanging out there. It's an additional storage of fat in our body that just hangs out right along the large intestine. Now, regions of the large intestine, again, some nice lab review. The cecum, so after food leaves the small intestine and goes into the large intestine, yes, the downward first little pouch is called the cecum. Then, and hanging from the cecum, you have the appendix. Then you have the colon. I go through all the parts on another slide coming up. You have the colon, the largest part. You have the rectum, the straight up and down. That's where the rectum name comes from. And then you have the anal canal that leads out. It's all large intestine. It's just different regions of the large intestine. But it's all large intestine. Now, the cecum is just the first part of the large intestine. The appendix that hangs off of it. And is the more interesting part of the large intestine. So it is part of the lymphatic system. It isn't something we need. People can have their appendix removed. Has any of you had their appendix removed? Just you? It's like just one? I feel like more people have had appendixes out. And so it is part of your immune system, but it is not needed. And so a lot of what's hanging out in your appendix is additional bacteria. Everyone's like, bacteria is bad. Bacteria is not bad. You will learn this in micro. Bacteria is not all bad. It just gets a bad rap. And there are lots of good bacteria, so many good bacteria. And we keep extra good bacteria stored there. So it can recolonize the gut when necessary. Now, for people that just got done with a huge fast and didn't eat anything for a week, well, they've got nothing in their intestine, including bacteria. That can be actually harmful. And so you've got bacteria stored in your appendix that can recolonize the gut. And however, because it's just kind of hanging out there, it happens that it can become twisted, or where the bacteria come out, that kind of little duct right there, it can become blocked. Now you have bacteria in there, and bacteria are going to do what bacteria do, which is reproduce. And if they can't get out, that's when it becomes appendicitis. It's inflammation of the appendix. You have trapped bacteria in there. Now, the biggest problem with appendicitis is what? When it ruptures. And because if it ruptures, what ruptures out of it? Bacteria. And now you have bacteria in your entire abdominal cavity. That's bad. And so that's why if they are noticing that it will cause pain with the appendicitis, it's still an inflammation, and that's pain, they're hoping to get in and remove it before it causes that full bursting because of all the bacteria that's stored in there. And it's also one of the reasons, random factoid, people that ever go into space, they have their appendix removed before they go. Because if they had appendicitis when they're up there, what's going to happen? They're going to die. You're not going to do emergency surgery up there. And so well, we'll just remove it. You don't need it anyways. Let's just prevent that of ever happening. Now, the colon is the largest part. So after the cecum, it's really all colon until you get here. It's like all of this minus that and that. And and so again, nice review for lab. Different parts of the colon. After the cecum, you have the ascending colon. And then it does a little, they call it the flexure. The right colic, because it's on the right side of the body, or the hepatic, because it's right underneath the liver. The right colic flexure. Then you have the transverse colon. And you have a left colic flexure. Then you have the descending colon. And then you have the sigmoid colon, because it's kind of like an S. There you go. Different parts of the colon. Then it ends, the large intestine ends with the rectum and the anal canal. Now, the rectum has 3 rectal valves in it, one of them shown on my next picture, and the rectal valves stop feces from being passed with gas. We can all say a prayer of thanks for that. And that doesn't happen. Now, after the rectum, We have the anal canal, which is the last part of the large intestine, because it opens to the body at the anus. Now, in the anal canal, you have two sphincters. You have an internal one that's smooth muscle, and you have an external one that's skeletal muscle. Which one can you control? You can control the external skeletal muscle. And I'm like, which means even though you may need to defecate, if that is not opportune, I mean you're not in the bathroom, and I'm like, you can hold it in, hopefully. You can hold it in with that skeletal muscle that you can control. Now, at the top, you can see one of those rectal valves that crosses over. Otherwise, you have part of the rectum, part of the anal canal. This table is just annoying me. I don't think I have to draw anything. Then you have the two. You have an external anal sphincter and an internal anal sphincter. You have the internal one that's made of smooth muscle that you can't control. And you have the external muscle that you can control, hopefully. And I'm like, to eventually hopefully squeeze, and keep it closed until defecation is at an opportune time. I think one of the videos talks about if it's opportune or not. Now, if we looked inside of the large intestine, a couple unique things for the large intestine. The inside mucosa lining is thicker, but it's still made of a simple columnar epithelium. The only place that you don't find the simple columnar epithelium is at the very end of the large intestine on the external anal canal. And I'm like, that's where you've got stratified squamous to withstand abrasion, aka wiping. And I'm like, so when you are wiping, all that extra abrasion, your body is adjusted to handle that and is made of that stratified squamous epithelial. Otherwise, the rest of it has the simple columnar. There aren't any circular folds. There are no villi. There are no microvilli. There are no digestive secretions in the large intestine. By the time the food gets to the large intestine, everything was broken down already. Just about everything was absorbed already in the small intestine. And I'm like, really? And I'm like, the one thing it does have additional goblet cells in the mucosal lining. Goblet cells make mucus. It's just to help in the aid of moving the feces along. And I'm like, because by the time it's large intestine, we don't call it really food anymore, it's fecal matter. And so that mucus just helps move the fecal matter along. You do also have some veins that are found in your anal canal. And I'm like, they're venous plexuses. The problem with them is these veins near the end, I'm going to say, of the anal canal. And I'm like, those particular veins can become inflamed. They can enlarge. And I'm like, that's where we get hemorrhoids, is really enlarged veins found in the anal canal. Now, and I'm like, that in itself is going to be painful every time you defecate, because you have these large veins that can protrude inside that anal canal. If they are large enough, they can protrude outside of the anal canal. And I'm like, and it's going to be painful for sitting, painful for defecating. Now, this happens more often as you get older. Another thing to look forward to. And I'm like, and part of the thing that prevents it, and one of the reasons why it happens in elderly, is when you're constipated. The force it takes to try to get that dry fecal matter out of your intestine is hard on those veins. Like, it's extra force that's damaging those veins to cause them to become inflamed. So as you get older, constipation is more likely, and constipation is a top thing that causes hemorrhoids. Now, in your intestine, there are bacteria. Bacteria are good bacteria. Now, they hang out in your large intestine. Some of them came from the small intestine, some of the stuff you ate. Some of them came from the anus, but they're going to hang out in your large intestine. And they're going to hopefully hang out with you forever. Now, good bacteria do good things. There are bacteria in your intestine that make vitamins. Bacteria make vitamins. They make some B vitamins, they make some K vitamins. They can also help break down some additional food. If food didn't get broken down in the small intestine, bacteria can help further break down some of the food. And I'm like, that are in there. They do also ferment, break down, indigestible carbohydrates. That's your fiber. And I'm like, so they do try to break down some of that indigestible carbohydrates, the fiber. Now, when they are fermenting it as they are trying to break it down, anytime you ferment anything, it's going to release gases. This is where flatulence, this is where your farting comes from. You wonder where the gas came from? Well, it's your bacteria trying to break down some of the carbohydrates that are in there. What they're breaking down and what bacteria are in there breaking it down gives that, nice aroma of different smells. And I'm like, depends what you ate and depends what bacteria are trying to break it down. But you make about 500 milliliters, about a bottle's worth of gas every day, whether you knew that or not. Now, other than just having bacteria in there are some viruses that hang out in your intestine. There are some protozoans that hang out in there as well. And I'm like, most of them don't really do anything good, and so some of them just hang out there. More of them are bad, than anything else. But we do find some viruses and protozoans that hang out there. But because we have so many things in your intestine, bacteria, viruses, and protozoans, all hanging out in your intestine, our intestine does have to be equipped to prevent that stuff from getting out of the intestine. And so we have to prevent bacteria as well as other things getting across the intestine and causing us issues. So part of it is we have epithelial cells that recruit dendritic cells that recognize foreign invaders and tell the immune system to get rid of them. They tell the immune system. And I'm like, but they're just constantly, your large intestine is patrolling for invaders. And your bacteria has a lot of possible invaders. Am I almost out of time? I have 5 minutes. Now, digestive processes in the large intestine. Again, most stuff is broken down by the time we get here. And so their residue just hangs out in there anywhere between 12 and 24 hours. Sometimes it depends on how much you ate, how active you are. But really, the only food that does get broken down in there is the food that's broken down by the bacteria that are in there. Otherwise, we don't make enzymes or do any kind of physical breakdown. The only thing that really gets absorbed in the large intestine, because most of everything was absorbed in the small intestine, a few vitamins get absorbed there because they're made there. So if the bacteria make vitamins, we want to be able to absorb them. We can absorb some electrolytes. We can absorb some water. But the main goal of the large intestine is to get fecal matter out of the body. Now, the note, your colon is not essential to life. It just moves stuff along. People can live without a colon. And I'm like, all the digestion, all that absorption is taking place in the small intestine. You can have a colonectomy. They can remove the colon. And I'm like, all they're doing is moving food along. Now, as we move stuff along, because you have to move stuff along, you have haustral contractions. Those are those little pouches that are moving stuff along. But most of the moving along is all based on a reflex known as the gastrocolic reflex. Is that once there is food in the stomach, everything, nervous system is telling the brain to tell the large intestine to empty it. It's almost kind of like food incoming. And I'm like, and if food goes in, food has to go out. And so the reflex, food goes in the stomach, whether you realize it or not, after you eat something, is normally the thing that triggers you that you have to go to the bathroom. This is very predominant in dogs. You feed your dog has to go number 2. And I'm like, they usually go, several times a day. I'm almost done where I want to get to today. Now, problems that can happen with the colon is if you don't have enough fiber in your diet. And I'm like, it's the big thing that causes it. Your colon wall will start to get small. And when it does try to squeeze that fecal matter through, that squeezing on a small colon can cause it to actually start to inflame and even start to bulge out. These little bulges, they're called herniations, little bulges of the large intestine are called diverticula. And so if someone has a lot of these, it's called diverticulosis. Problem is, if they become large enough, they could rupture. And guess what's in your digestive tract? Food and a lot of bacteria. And I'm like, and I wouldn't even say food, I'd say fecal matter, which is mostly bacteria. And we do not want fecal matter and lots of bacteria rupturing outside of the intestine. It's very painful. It could be life-threatening. Now, some other things that can happen, something known as irritable bowel syndrome. It's a functional digestive disorder. And I'm like, we don't know if it's a hormone imbalance, a bacteria imbalance, and I'm like, there's several things that can cause it. And I'm like, but it's going to cause pain, it's going to cause stool changes, bloating, flatulent nausea, and even lead to depression. It's almost like a nonstop irritant to your large intestine. A lot of things that can precipitate or start it is stress. But I'm like, but there's, people that are like, I'm not stressed, and can still suffer from it. They're not exactly, there's not one thing that can cause it. I want to get to, getting, I got like 2 more slides. And I'm like, defecation is, let's get food out. And I'm like, it's a mass movement, getting the fecal matter out. Distension, which means stretching of the large intestine, is going to trigger defecation. Now, it's a reflex, and so your parasympathetic nervous system, your rest and digest, is going to cause contraction of the colon. It's going to relax the internal anal sphincter, and if defecation is convenient, and I'm like, you can control that external anal sphincter. Otherwise, you got to hold it in. But it is a reflex that's telling everything else to relax, the one sphincter, and squeeze things along. Now, the muscles of the rectum help squeeze the food out, but to help it along, there is something known as the Valsalva's maneuver, which it is a respiratory thing, so it's a little review of respiratory system. The Valsalva's maneuver is you close the glottis opening in your throat, you contract your diaphragm down, which causes increased intra-abdominal pressure. It's the reason why, whether you realize it or not, because you will know, and I'm like, when you defecate, you hold your breath. Oh, it's like you're like, and I'm like, that's what you're doing. You are literally closing it off. You are pushing down on the diaphragm, and you're trying to create more intra-abdominal pressure. The more pressure that's in there, the less the feces wants to be in there, and it's literally trying to help push it out. And so I'm like, your rectal wall is squeezing it out, but you are as well by creating that pressure in there. This is just showing all the reflexes that's causing the various muscles to, I lied, I did have one more slide. And I'm like, what's diarrhea, what's constipation? I didn't know how to shorten it. And I'm like, diarrhea, watery stools. It just means you're not absorbing enough water out. The opposite, constipation. Food hangs out in the large intestine too long. The longer it hangs out in the large intestine, the more water gets absorbed out of it, which means you now have a dry, compact feces. And I'm like, it's harder to move along. So it's just one, not enough water gets absorbed. One is too much water gets absorbed. Things that can cause diarrhea, bacteria can cause diarrhea. It's your food poisoning. And I'm like, various viruses can cause it. Marathon runners, no, it didn't happen. And I'm like, but it can happen. And I'm like, running. That's why you hear people that, oh, I have to run. Oh, there's always hear the stories of the people that can't make it. But if you have diarrhea long enough, you're going to lose too much water. You're going to lose electrolytes. And I'm like, you have to replenish them. We'll get to there. I recorded starting right here because I wasn't sure how far we'd get. So things to do before I see you on Thursday. One, watch the last little bit. It's, how do we break down carbohydrates? How do we break down the lipids? How do we break down the proteins? How do we break all the different chemicals down? What enzymes do what? Watch that video, digestive exam on Thursday. We're also going to start the urinary system. So once you talk about poo, you got to talk about pee. So we're going to start the urinary system. There is an intro video to that as well. So there are 2 videos. So 2 videos and study for a lecture exam on Thursday. Thank you for letting me go 4 minutes over. My watch is 2 minutes slow.